Okay, this is a lesson for powers of 10, and I'm doing this to help you with the unit on powers of 10 on Khan's Academy. Also, your chapter, this is part of chapter 1, so it's a review. You will be needing this in 6th grade. You will be doing powers, and I'm going to go ahead and review this. The students that have already gotten 100% on Khan's Academy on this skill are Amy, Antonio, Belinda, Jonathan, Villa, and Emily. Good job. The rest of you, I want this week that you work on this skill so you can master it. I want you at 100%, and I will be sharing who gets to that on Thursday. So let's go ahead and get started. Here we have an example. The third powered of 2. Okay, the third powered of 2. So I'm going to go ahead and review the vocabulary. On the previous slide, you had to match some of these terms. So I just want to make sure that if you didn't get it right, then I can explain it to you. So here we have the 2, and the 2 is called the base. Okay, the base is a number. Is a number that is a repeated factor. So when we're talking about factors, we're talking that number that you multiply with another to get a product. So that's when factors are used in multiplication. In this case, the base is a number that we will multiply by itself. Okay, so we have the base. And now, let me get it closer. And on this side here, the arrow is pointing to the 3. And the 3 is written smaller, and it's on the upper right corner of the base. The 3 in this case is called the exponent. And so I'm going to write here, this one is the exponent. The exponent tells you how many times you're going to multiply the base by itself. So another way to rewrite this is, and I'm going to write it here. Okay, so the third power of 2 is equal to, so we will rewrite it, 2 is our factor, and we're going to multiply it by itself 3 times, because that's our exponent. So that's 2 times 2 times 2. Okay, make sure that you're multiplying, not adding. Okay, multiplying. So you would have to break this apart. You can do it in your head, or you can do one at a time. So 2 times 2 equals 4. So you could actually rewrite it so that you don't make any mistakes. 2 times 2 equals 4. And then multiply it by 2, so that would be equal to 8. So that's how we solve powers of 10, and that is pretty simple. Yes, I know, but you have to make sure that you're doing the right operation. You're multiplying and not adding, and you're not multiplying the 2 times the 3. You're multiplying the base by itself as many times as the exponent tells you. All right, moving on. Okay, so now we're going to move to another part of powers of 10, which is multiplying by powers of 10. So there's a few examples here of a few problems that you used to get on your quizzes, but it's also on Khan's Academy. And we still have a few of you a bunch of you that haven't mastered the skill on Khan's, and is multiplying by powers of 10. So we have here an example. For example, 0.516 times the second power of 10. So we already learned on the previous slide that the exponent tells you how many times you multiply the factor by itself. So you don't have to do this, but I do recommend you do it if you're struggling with this concept, to rewrite it and write the power of 10 as a whole number. So this is the same thing as saying 0.516 times, and then we saw the second power of 10. So the way that you do that is by multiplying 10 times 10. Okay, and what is 10 times 10? We know that it's 100. If you also remember, you look at the exponent, and that kind of tells you how many zeros will be in your after your 1. If it was 10, if it was -2 instead of 2 here, if your exponent was -2, then that would just mean that your number would be a decimal, and you would move your decimal point to the left instead of the right. So in this case, we just made it a little simpler. And now I can multiply 0.516 times 100. Okay, so I need to make 0.516 100 times as big. So if I'm going bigger, that means that my product will be bigger. So think about it. If I move my decimal, how would I make it bigger? Going to the right or going to the left? Well, yes, it would be going to the right. So if I'm multiplying 100, I have 2 zeros. Or if you look at your exponent, it's 2 zeros. So I know that I need to move my decimal point 2 times to the right. 1, 2. So 0.516 times 100 equals 1.6. Okay, I don't need to add more zeros after that. And that's my answer for that one. Now here we have 0.516 times the third power of 10. So now I'm not going to rewrite it. You can. If you were to rewrite it, you're multiplying 10 times 10 times 10. So 10 times 10 is 100. 100 times 10 is 1,000. Or you can think, okay, 1 and then it has 3 zeros. So that would be 1,000. But I don't necessarily have to do that, because I can also just look at the exponent and know that I'm going to move my decimal point 3 times. Because it's a positive exponent, I am going to move it to the right. And so if I move it to the right, that's 1, 2, 3. So my final answer is 516. So if you notice, every time I increase my exponent, I'm also going 10 times as big. So what would be 0.516 times the fourth power of 10? Well, look at the pattern, 51.6, 516. So what could be the next number? So you want to look at all those things just to make sure that you're doing it correct. Again, you can also rewrite it, 0.516 times, and then solve fourth power of 10. That means that I'm multiplying, and I'm going to put in parentheses this time, 10 times 10 times 10 times 10. Okay, I don't have to do this. I'm just showing you in case you're still confused. But if you already know how to do this without doing that, go for it. So what is 10 times 10 times 10 times 10 times 10? Well, I'm going to rewrite it again. Okay, you will have 4 zeros after the 1. So that's 0.516 times, and then we have 4 zeros. 1, 2, 3, 4. And I'm going to add Okay, so that's 10,000. And now when I solve it, I know that I'm moving my decimal point 4 times. 1, 2, 3. Oh, but I don't have another digit. Well, remember when we did this lesson in chapter 1, or when we did decimals, there's no digit there, you add a 0. So your final answer would be 5,160. Okay, another example problems that we can find on cons is compare decimal place value. So here we have the value of 5 in 39,560 is blank times. So how much bigger is it or smaller than the 5 in 95,147? So it's very wordy, but what you're doing here is you're comparing value of the 5 in both digits. So if you're comparing the values, you need to identify what is the value on each. So let's look at our first number, 39,560. So the 5 is in the hundredths place, right? So I'm going to write it down here, the value of the 5 on this first digit. So the value of the 5 in 39,560. The 5 would be 500, right? Because it's in the hundredths place. And now I'm comparing it, and I'm just going to put it blank, to the value of the 5 in 95,147. So the 5 here is in the thousands. So that 5 is equal to 5,000. So now if you look at it like that, it's so much simpler than all this wording here. So now I'm saying, okay, is 500 10 times bigger than 5,000? Or is it equal to 5,000? Or is it a half of 5,000? How much bigger is it? Well, in this problem, and I pull an example, not the exact numbers, but I pull something similar to Khan's Academy. This number, I would say, is 1/10, right? Because 500 is 10 times smaller than 5,000. So the answer here will be 1/10 of 5,000. How can you verify that? Well, 500 is smaller than 5,000, so I know this is going to be a fraction. 5,000 is 10 times bigger than 500. So if my 5,000 was on this side, or if it was my first number, then I would say it would be 10 times bigger than 500. But in this case, I'm going the other way. Okay, so that's another example. Now, make sure that if you have any questions, you let me know. All right, and that'll be it for this lesson, Powers of 10.